was giving me a little bit issue. So this morning, I'll be presenting to you, as you can see on the screen, on building AI-powered recommended system with back-end APIs. As we all know that AI has taken over the world, and the world is getting more digitalized every day. And the world of technology is being expanded. So I'm going to be talking on recommended system as one of the most impacting applications for artificial intelligence, how they help us discover relevant products, movies, videos, music, and content based on interest. Now, think about a recommended system as a friend. You have a friend that knows what you like, that knows what you want. And if that friend happens to give you something, if that friend happens to give you a gift, is going to give you something that he knows you want. So that is how a recommended system is. So now, we want to see real life examples. These are the real life examples of the recommended systems we have. Real life examples. We have the Netflix movie suggestions. If you are watching on Netflix and then the system discovers that you like a particular type of movie, probably an action movie, probably Christian movies, the algorithm begins to bring similar kind of stuff to you.
Sorry, please. We cannot concentrate on what you are saying because somebody's mic is on mute. If the admin can mute everybody, please. I'm not even hearing anything you are saying because someone's mic is on mute and the person is disrupting the whole thing.
Hello. Please.
Adogo, can you, man, please mute your mic.
All right. Sorry, I'm so sorry for the interruption. Sorry. I'm talking about a recommended system as the order of the day, as the advent of AI today. And I was talking in the previous versions about how recommended systems work. And think about a recommended systems with backend API as a friend that knows what you like, knows what you want. And a friend that knows what you like and knows what you want, whenever he or she wants to give you a gift, is going to give you something similar to what you want and to what you like. And these are the real world example we have. And the Netflix movie suggestion. For some of us that like watching Netflix, when you go on the net and the system recognizes that you watch a particular movie, probably a Christian movie or an action movie. So the algorithm begins to suggest similar kind of movie to you. And also another reward examples is Amazon product recommended. If you usually purchase things on recommendations, if you usually purchase things on Amazon, you discover that you are someone that like a certain brand of, let's just say a child that like a toy. If that child has purchased a toy before from Amazon, the system begins to suggest kinds of recommendation to them. And also YouTube video feeds and Spotify's playlist. And what is the business values that the AI recommendations backend APIs has brought to us by showing content users are more likely to interact with. Yes, when you are engaging with the systems and you are interacting with the systems, there is that personalized is similar. Also, thirdly, they improve customers' retention because users are more satisfied. They receive you receive very recommendation. You like purchasing something similar to football. Let's just say football accessories like jerseys or boots And when the system sees that that is what you like, the next time you want to purchase on such a system, it might suggest it might suggest a ball, or it might suggest an hand glove. So that is how a recommended system works. And we want to see types of recommendation, because as a back-end engineer, when building these recommendation systems, we must know how it works. It's not about, for some of us, we have been using it, and we are to be more kind of conscious on how it works. And at this particular segment, I'll be talking on how it works. And how it works, you can types of recommendation system, which is the content-based filtering. The content-based filtering. And this filtering, it means it recommends similar items to those a user has liked before. I'm using Facebook now as an example. Facebook is a very popular social media kind of social media network that everyone is in today. Now, if you like a particular post that is similar to politics, the system brings another similarities of information that has to do with politics also. That is the content-based filtering. Now we have the collaborative-based filtering. I want us to, get the difference between the content-based and the collaborative-based filtering. Now, the collaborative filtering doesn't have to do with you in person. Doesn't have to do with you in person. It has to do with a third party. The system is the first party, and you are the second party. Now we have a third party. Now the system is looking at the third party, trying to see what your friend like. Now it doesn't attach to you. I like a particular stuff, but my friend does not like it. Now the system might suggest what your friend like and suggest it to you. It also happens on Facebook also, that I might be friend with, for example, now, I might be a friend to someone you know. And normally, I have no connection with you, but you might not know that I know that person in particular. Now, the fact that I know your friend, but you do not know that I know your friend, the system will suggest it to you. That, do you know friends you may know? We usually see it on Facebook, that do you know so and so. So that is a collaborative filtering. It has to do with two people. Now the content-based filtering has to do with one people, while the collaborative-based filtering, it has to do with two people. While the hybrid models, it comprises of both the content-based filtering and also the collaborative based filtering. Now, data needed for the system to be able to process information. It is the clue that computer uses to understand what a person is like. Yes, without data, the computer is like a blindfolded child trying to get, access to favorite toys. Yes, like, without information, the system might not be able to process all these things. So number one, the system needs the user profile. The user profile such as age, favorite hobbies, interests, preferences, and the likes. Also, the ratings, click, like, and watch. These are what the system works on. These are the signal that shows what you enjoy. And the movie you algorithm. And we also have the purchase history. This one now is particularly for those online shopping and those online platform that you can buy or get some things. Once you purchase something, the system also brings similar items to you to purchase, and also can also see the item melter data. This information is about the item itself. Information is about the item itself, Like for example, now you have a product category, the electronics and the clothing and all that. So if you're enjoying action movie, the system finds another movie that is labeled to such an action. So also want to see the machine learning pipeline that the system work on. Machine learning pipeline that actually the system work on. And that is number one, we see data collection. Data collection, the system gathers informations that includes what user clicks, what they watch, what they buy, what they like. For example, if you watch many football movies, system stores the informations. The system have the information that you watch many football movies, and this is like gathering flours, eggs, and sugar before baking. Like the information they gather, that is data collection. They gather information is like you want to cook rice. Let me just use that basic example. You gather your ingredients, you gather your rice, you parboil it, you make up preparation kind of cook. So the system also gathers in like manners, and also it cleans and transform. It cleans and transform. Just like what I said, after you get your rice, you wash it. You wash your rice. If you are using salt, you peel your Maggi and all that. Those you are it's undergoing through a kind of a a clean process, a kind of an evaluation process that will make the system run smoothly. And we also have the train modem, and this is more or less like let's call it like now you can teach the computer using data prepared. Yes, the computer learns patterns, and such as people who like action movies also like also get some similar, and also the system evaluates and deploy. Now, this one now we are more or less talking like a programmer. This is the machine learning pipeline we use to develop such a statement. And it's not just developing, don't come around, you understand how it works. You understand the models, you understand the principles, you understand the structure of how it works. Then if you want to build such a system, you have to go through this pipeline in writing your codes, the data, the collection of data, and also you make sure that you arrange your code very well. And also you test the model, that is the train model. You also evaluate and deploy. You also evaluate, deploy the modem, and repeat the new data. And also, we also want to discuss about the popular algorithm use. We are saying about the similar thing just for us to, get access, just for us to like, understand more on how these, systems work. It's just a natural logic that every one of us can apply to our lives. Every one of us can apply to our day-to-day lives. The system is being programmed that way. And we thank God that we have a lot of organizations, and most of the app being developed today as now the AI recommendation system has now been integrated into such kind of software. Hardly will you see softwares today that that AI integration is not being kind of being kind of integrated into it. Everyone wants to flow with the technology, the new advents, and all that. So that is why we want to understand this algorithm very well. And so popular algorithm, we have the causing similarities. Yes, causing similarities. It's more or less like what I said earlier. Like I am, let's just say I'm a twin. I am Kende, and I also have my twin brother, which is Tai. Now, I love ball, I love books, and I love beef. Now, my brother, which is Tai, he love ball, he love books, but he love fish. Now, we have a causal similarities between us, between us. I love three things in which one is different. Just that one that is different is the causal similarity. And this algorithm is being integrated into the system to work perfectly. And also, we also have the matrix factorization, the matrix factorization. And just imagine you, imagine a giant table, roles as users, like like you draw a box, and that number one, I'm the number one there on that box, and number two is Kende on that box. And that margin, the first box is filled. We have the same similarity in the first box. The second box, we have the same similarity in the second box, but the third box is different. So this is just a metric, factorization. And we have the neutral network, the neutral network. That is, we are both close to each other. We are both close to each other. Our similarity is not that different. We are just neutral. We are similar to each other. And let's look at the back edge architecture, API architecture, how it works in particular, how the systems work in particular. And we also use a real life analogy, a real life analogy. Like, for example, you went to an eatery, and you went to the eatery now. The first thing is their procedure, their blueprints for you to get what you want in the eatery. You can't just go to the eatery and go directly to the kitchen and get your food. No, there is a procedure, there's a measure you need to pass through. For of us, you go through the waiter, you tell the waiter what you want. The waiter process your request and give it to the chef. And when the information gets to the chef, to you, it doesn't have any connection with you. End API architecture as like that. And whatsoever application you are using is representing you. Whatsoever application you are using is representing you, or representing the waiters. Yes, rather. Now, client sends requests on that base. The request you send is being processed by the request you send is in processed by the waiter. Now, the waiter loads modem and then give it to the chef. Give it to the chef, and when the information gets to the chef prepares your food and bring it back to you. So that is how it is in the real world now. And also, it's like let me use an application as an example. Let me use an application as an example, like the Netflix application. Netflix application, when you open the app says, please get recommendations. Yes, when you open the app says, please get recommendations, and the request user ID. For example, if it's like saying to the waiter, I want fried rice. The waiter loads your process. Now, the process is the API loads model. Yes, the back end, the API receives the request and opens the smart AI. The model already knows how to make recommendations. So that is it. And so what process your request in particular? Your request is being processed and sent to the back end. So this is the back end API, architecture. And tech stack, the tech stack we use for the recommendation AI, the most relevant, the Python, which is majorly a very popular language we use to build, comprehensive and new model system. And also it tells the computer process data and the likes of that. And also we also have the fast API of Flask. Yes, you can call it either Flask or a fast API. This is majorly what we use for the generative AI. Generative AI, how unique it is. This is what we use. And also we also have the scikit-learn and TensorFlow. These are tools that teaches the computer how to learn. These are tools that teaches the computer how to learn. So they are like a teacher, like, from the computer. They help the systems learn pattern, understand users' behaviors, and, make, predictions. And the database being that we can use that we are all familiar with per se, majority of us as a web developer, back-end web developer, we can use the Postgres and the Mongo database. So that's the likes of that. And also sample API endpoints. Samples API endpoints. Number one, we have the get recommendation user ID. So get recommendation user ID is more or less like it give me recommendations for users. It give me recommendations for users. And how does this work? This is like walking up to the assistant and saying, what should I buy? What should I buy? And the systems look like your ID and reply that movie you can like, songs you can enjoy, and products. When you ask the system that what should I buy, and it brings out suggestions to the information you feel to the system. And also we also have the posts, and you can also call it the feedback. And this is also the system that tells what user like or click, what user like or click. It's a system that tells what the user like or click. You are on a system and you are liking a particular stuff, a particular movie. This is what sends information to the system on what you like and also what you click. And also we also have the GELT and health. The GELT, which is also called the health. This is like what process your information, like, is the system working? Is the system working? Let me use a baby explanation. Like, this is like asking, are you okay? The system replies, yes, I am okay. This is just an AI generational flow works, and it works fully. As I said earlier, the real life example are what we are familiar with. The real life example are what we are familiar with that make sure it's smooth. And real life example like the likes of the Netflix, which we used to watch movies, and I said that it brings out movies similar to the one you have watched before. And then we begin to ask ourselves that how is this thing being programmed? How, even when you are new to, maybe you are just opening the app for the first time, it's maybe when you are filling your information during your when you are filling your information, when you want to sign up, it gives you some information, your likes and your this and that. Immediately you sign up, you might be very surprised that the first video that pop up will be the one you are more interested in, will be the one you like based on the information. And sometimes it brings out the likes of what other people, even if you don't put like what you like, maybe your favorite, maybe it asks of your age, it brings out what young people like in that circle. Whatsoever it brings out is related to the circle. And so all that, we have also the deployment options. That's also the deployment option. So this is a stage where you put your system online so that people can use it anytime. People can use it anytime. For some of us, we have deployed some app before, and we know how it works. So we have the number one, the Docker, the traveling box Docker, and it's like, let's just say, like, let me give it a literal explanation. The Docker is like a magic lunchbox that packs everything your app needs. Yes, it packs your codes, it packs your tools and your systems, like your systems features. So when you move it anywhere, it still works perfectly. So it works on your laptop, it works anywhere. And also, we also have the cloud platform. The cloud platform is a big house, online house. The cloud platform is online house, and examples are the Amazon Web Services, the Google Clouds, and also the Microsoft Azure. So now we also have we also have the CI and the CD. That is the continuous integration or the continuous deployment pipelines. Yes, the continuous deployments or the deployments, deployment pipelines. And this is more or less like a robot that delivers the systems from your apps updates. So whenever you make a change, it tells your code automatically and checks it for error. Yes, and checks it for error. So these are the instruments used for deployment so that you might not by chance have an issue. So also have the challenges and the solutions, the challenges and also the solutions. Cold start problem, new users or items are little or no data. So this cold start problem, now it gives you informations about the popular items. And also we also have the data sparsity. Most users interact with only a small fractions of available items. And also we have the scalability and lengthity. So the future trends of recommendation systems, the generative AI recommendation system, which is the orders of the days, the real-time personalization, and also the explainable AI. So I want to know if anyone have a question. Have a question, I want to know. Does anyone have a question? Yes, sir, Mr. Innocent. You can ask your question, sir.
Good morning, sir.
Yes, sir. Good morning, sir.
It was a very wonderful, brilliant, insightful presentation from you. I'm seriously impressed and I learned one or two. So my question really is, you were talking about recommendation systems.
Yes,
And
sir.
then I later discovered that you to APIs. So I saw one of your slide where you were talking about APIs and all.
Yes.
So I just wanted to ask. I believe the reason why you are showing APIs to like tell us how the recommendation systems are using API, or correct me if I'm wrong.
Yes, yes.
So so can you like practically like show us more on that aspect on how those APIs are working with the recommendation systems. In case maybe someone here wants to build maybe something, and how can the person now access those APIs and all. And also, if you are then building, that's the second part of my question. Where can we now find these APIs that those the services are already done, and then you can just connect with the API and build a product, either AI or whatever. So that's my question.
All right. The back-end API, as I said earlier, is more or less like a framework. It's more or less like a framework. And let's assume you want to build an applications like an AI chatbot that's you know that can recall memory, it recalls memory automatically, that once you tell it your name, you will never have to come back and tell it your name. Let's just assume you want to build such. You look for the latest the latest trend of the API kind of software. Sometimes look for the flags and look for the flags. Yes, the flags API. And also, you also discover that while running the API systems, you might have some errors. You might have some errors on it. But you as a developer, you must understand the flow chart first. The flow charts, what you need to do, like the back-end API architectures, client sends requests, and API load models, API recommendations, and all that. So that is it, sir. I don't know if I've answered your question.
Yeah, you mentioned Flax API. What's that? What's Flax API?
Yes, a framework that you can use to develop your application. So, like, are you listening to me, sir?
Thank you so much.
All right, sir.
All right, thank you very much, Joshua, for that beautiful one. Thank you for that insightful one at the